What is bearing? Bearing is nothing but an angle measured from the north for any line in a clockwise direction. So any angle measured from the north, magnetic north that is known as a bearing. There are two types of bearings. One is called the forebearing and other is called the back bearing. Or we can short with FB and BB. When we process our compost survey in this direction, which has been mentioned by arrow over here in this direction, then this line AB makes an angle of theta with A, or we can say with north, of course, with related to north, we can say that the forebearing of AB is theta. But when we talk in terms of this angle, again it is clockwise also again, but going in this direction, not in the direction of the progress of the work, but opposite direction. Then we call this as a back bearing of AB taken from here. Always this is again as usual, this can call this as north. I can call this as a north. We can call this as a north. So all the angle which is measured from north. So forebearing is nothing but in a clockwise direction, in the direction of the progress of a work. And the reverse direction we call the back bearing, and that is the angle theta like this. And from this we can see the difference between the forebearing and the back bearing is 180 degree, because this angle is equal to this angle. So this is the back bearing and this is the forebearing. This is also a forebearing. Then the difference between the two will be only this much, 180 degree. So it is always to be taken into consideration that the difference of a line for the bearing taken from in the direction of the progress of work is called the forebearing, and in the reverse direction we call as the back bearing of line AB, and the difference between the two forebearing and back bearing of the same line is always 180 degrees. 180 degrees it is always there. But before we proceed for the next part, that is, if it is changing from 180 degree to 178 or even 180 to 202 or something like that, why this change takes place? Because as per the principle, you must get the difference between the forebearing and the back bearing of line AB is 180. When I am not getting 100 difference between the two is 180 degree between these two, there is something wrong somewhere, that the magnet is not showing, that needle is not showing the correct reading. Why the magnet is not showing the correct reading? Because there must be some local attraction. There must be some local attraction is there, just like our watch is there, our cycle is there, our motorcycle having some something that comes out that attracts the magnet, that is related to iron, etc. Railway track is going on there. At that time, the deflection will change, and at that time you'll find that the difference of the forebearing and back bearing is not 180 degree. Either it will be less or more than 180 degree. So when the difference is less than or more than 180 degree, now we can say that there is some local attraction, and because of that local attraction, this deviation of angle takes place. This deviation of the angle takes place. And then in a succeeding process, we'll calculate that how much local attraction is there, how much deviation is there, and how it can be corrected. But before we proceed for the bearing, now we have already studied there are two types of compass. One is a surveyor's compass and another is a prismatic compass. In a surveyor's compass, it is 0 to 360 degrees, while in the prismatic compass, it is 0 to 90, 90 to 0, again 0 to 90, 90 to 0. From north to east, it is 90. From again east to south, again it is 0. From south to west, again it is 90. And from west to north, it's 0, that is 90 degree. So now what we have to do, first of all we have to see one process in which we are calculating the direct angles like this, which is taken from the north, and taking clockwise like this, having 4 quadrants: quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. This is 0 to 90, 90 to 180, 180 to 270, and 270 to 0 and 36 degree. All the angles are measured from the north. When it is in first quadrant, there must be a bearing. We can call this, it is from in a quadrant 1. If it is exceeding 90 and less than 180, it is in quadrant 2. If it is more than 180 but less than 270, it is in quadrant 3. And when the angle exceeds 270 but less than 360, it comes in quadrant number 4. Similarly, let's see, I have given some angles of 60 degree, 120 degree, 210 degree, and 350 degree. 15. Here you can see, this is the first line which makes an angle of 60 degree with normal north. It is in first quadrant. Secondly, the second line goes like this and it comes over here. This is 120 degree, and the angle again starts from here and reaches to this line. Third, 210 degrees. It goes like this and comes over here. Fourth, it goes like this and comes to the fourth quadrant. All the angles are measured from the north, and this is called whole circle bearing. This method is known as whole circle bearing. In short, we can call it WCB, whole circle bearing. There is another process that we have just seen about the surveyor's compass. If that would have been a prismatic compass, then matter will be slightly different. Here now. Same thing now here. Same thing that you find over here. North, south, east, west. 0, 90, 0, 90, and 0. One important thing in this case, it is divided into quadrants only. So at all the times, no angle will exceed 90 degree. But if the angle is 120 degree, how it can be defined? We know it is in the second quadrant. Under such circumstances, If it is in second quadrant, that is from south to east. That is, if total angle is say 60 degrees, first I am talking about this, we can call this as a n 60 degree east. Whatever the angle which has been created from the north, clockwise direction. Clockwise direction. And next is this is the north, then this will be east. So in between north and east, so we'll call this as n 60 degree east. Now it is 120. Because there is no 120, so we'll have to take this angle from here. Angle from here. And now it is anti-clockwise. Always either consider from north or consider from the south. If it is in second quadrant, go anti-clockwise. If it is in the third quadrant, go clockwise. Similarly, if it is in first quadrant, go clockwise. If it is in fourth quadrant, go anti-clockwise. And it is from north, itne degree west. Here south, itne degree west. South, itne degree east. North, itne degree east. This way, this is called reduced bearing, or also called as a quadrantal bearing. Also known as quadrantal bearing. Just for example, if I will talk about 60 degree, it is lying in quadrant 1. So when we are talking about the quadrant 1 means here it is 60 degree. So how we will write this? N 60 degree east. About 120 means it is lying over here. This is 120 means this is 60 degree. This is 60 degree. And we have to go in this quadrant. So how we will write it? S 60 degree east. Similarly 210. So 210 comes over here. How much this will be? 30 degree. It will be S 30 degree west. And when I am talking about the last 315 means this angle is 45 degrees. So we will say north 45 degree west. So how to convert that whole circle bearing into the reduced bearing? We must read it carefully. Vice versa. Vice versa. If the reduced bearing or the quadrantal bearing is given, how to convert it into whole circle bearing? Just take the reverse case. That is, if suppose this given as S 60 degree east, means this angle is given. But we are supposed to know in the whole circle bearing, we know this angle is like this. And this angle is, so we can say 180 minus theta will give the whole circle bearing. But if it is in the third quadrant, that is 210, we can say it will be 180 plus theta. 180 plus theta is equal to whole circle bearing. If it is 315, means this angle will be like this. So we can call 360 minus theta will give up automatically 350. So here again, this given as this much, so it can be converted as 360 minus this will give this angle whole. So you must be well conversant how to convert that whole circle bearing to the reduced bearing or reduced bearing to the whole circle bearing. After this, we'll go for how to calculate the included angle, if it is a closed traverse, and then correction because of some magnetic error, we can say, or we can say because of some correction. So after this we'll continue the same for the next part is just to identify the forebearing and back bearing, and then calculate the interior angle of it. So we'll continue with the same thing when we'll have the next video, please. Thank you.